This is activity 3 from lesson 2, quadrilateral on a circular grid. And what it asks you to do is look at this quadrilateral A, B, C, and D, and using point P, dilate each of these points out with a scale factor of 2. So you're going to make them move from their present points twice as far away from P, so a scale factor of 2 along a line starting at P. So A goes to A prime, B goes to B prime, C goes to C prime, and D goes to D prime. Scale factor of 2, this is 1 unit, 2 units, 3 units. So this is 1 unit, 2 units, 3 units. So a total of 6 units because 2 times 3 is 6. So each one of these are 3. Oh, actually, that's not true. This is 1 unit, 2 units, 3 units, 4 units, 5 units. So 2 times 5 is 10. So 1, 2, 3, 4, 5. This is 1 unit, 2 units. 2 times 2 is 4. And 1 unit, 2 units, 3 units, 4 units. 2 times 4 is 8. So 4, 5, 6, 7, 8. So each one of these actually is a different number of units away from P, but the scale factor in each case is 2. So those distances get multiplied by 2 to end up at A prime, B prime, C prime, and D prime. Connect the points, form this quadrilateral. So what you notice, or what I notice, is that first of all the sides remain parallel. Corresponding sides are 2 times longer. So this side here from B prime to C prime is twice the length of B to C. And A to B is 1/2 the length of A prime to B prime. If I took this line in Docerian, just made a copy of it, and moved it down here, you would see that this is same number of units. This is 1 unit, 2 units. A little bit hard to count on these, 3, 4. So this is 1 unit, 2 units, 3, 4. So a little bit hard to count because it's a circular grid, but each length is twice as long. Corresponding angles all remain congruent. So you're basically translating each of the angles out as you do the dilation. So each of these angles remain equal, so they remain congruent. Okay, so it asks you to add a few more lines and a few more points and transform those points, dilate those points out from P. So it's a straight line from P, and they're twice the distance. So they will end up on this quadrilateral. So this point goes to here, and 2 times it is 1 unit, 2 units, 3 units out. So it's going to end up 6 units, 3, 4, 5, 6. So they end up on the larger quadrilateral because they are also being dilated with a scale factor of 2. And so you connect all of these points. All the corresponding points to A, B, C, D that are on A prime, B prime, C prime, D prime lie on a straight line. So you can draw a straight line between the center of dilation and the original point out to its corresponding point. So that's how you actually locate that on the dilated image, how you move this image of B to B prime. So along a straight line from the center of dilation. All of the points on A, B, C, D are midway between A, B, C, D and A prime, B prime, C prime, and D prime. Midpoints of dilation. This is not stated quite right. All of the points on A, B, C, D are midway between point P and A prime, B prime, C prime, D prime. So this should be point P, not A, B, C, D. So this quadrilateral is midway between the center of dilation and the larger, the dilated figure. Then it says dilate this same quadrilateral, but use a scale factor of 1/2. So now you're going to take each of these points and make them 1/2 the distance away from P. So instead of 1, 2, 3, 4, 5, this is 2.5. This is 1.5 instead of 3. This is 2 units instead of 4. And this is 1 unit instead of 2. So each one of these moves half the distance from P than its original quadrilateral. So the quadrilateral basically is shrinking by that scale factor of 1/2. The angles all remain the same. So in dilations, the angles do not change size. All points on EFGH are midpoints between, I stated this one correctly, midpoints between point P and ABCD. So all of these points on the pink quadrilateral are halfway or midpoints between P and the larger quadrilateral, halfway. All right, so that is activity 3 from lesson 2. All right.